Hello, this is Anthony Pagan. In this presentation, I will be discussing the Data 612 final project and will begin with its business case, then move on to objectives, methodology, and data description before delving into the R code. The business case for this project is to reduce the cost of time to resolution of a problem. The ability to select resolutions to issues from a list of FAQs can sometimes be a time-consuming task. Trial and error can cause prolonged downtime on a critical system. I recommend a system that includes the experience of other similar users working on the same scope of issues would help reduce time to resolution. The objective of this project is to find a dataset that includes historical resolutions to problems or answers to questions. The rank of resolution or answers can be given higher weights to answers that provide accurate resolutions or have high number of similar responses. The methodology would be to review the dataset for similar resolutions, ranks, and weight best resolutions to frequently asked questions. The data description, or what we're going to begin with our analysis with a question-answer dataset in Kaggle. The dataset includes 169 files with the columns article title, question, answer, difficulty of the questioner and answerer, and the article file. Now we're going to go to the R code. The input data section, we are reading only the files with the question and answers as a start. Each file contains details of a specific set of topics, and each file is saved to a data frame here. Then we update one column name and R-bind the three data sets to one data frame. In the review and transport section, we tabled the question and answer columns and noticed some nulls. So we set the nulls to NAs, then select the article title, question, answer, and the article file columns. And then we use only the complete set. And then we remove punctuations, set answer columns to lowercase, and add a count column to count the unique rows. The result reduces the row count from 3995 to 2793 and increases the column count from 4 to 5. In this section, we are taking all the text files to display a word and term frequency. This data is the raw data that was used to create the question answer files. The top words overall are city, language, and world, which is confirmed in the frequency chart as well as the word cloud chart. The second review splits the question answer files, which is the pair.txt file, and the raw data files that has the full verbiage of the text. From these plots, there is really not much correlation between the top words in the question and answer text and the full verbiage. So the best approach would be to match the search terms with the question and answer files, then link the results to the full verbiage for further information. This approach would rely on the accuracy of the question answer file. So the first approach attempts to use a sparse matrix to get similarity of questions to document numbers from the result of the bind tf idf function. The code displays a 5x5 matrix. This is just one example of looking at a specific document and looking at the scores of 830 versus the question on the left. The second and final approach was to use a query search code function from a link in the appendix that we modified for our data sets. It uses the vector source and vcorpus functions on the QA raw dataset. The code builds a TD matrix on the query term and a QA vcorpus doc. It attempts to find similarities between the query term and raw data and returns the questions, the answers, the similarity scores, the number of similar answers, and the answer article file name. We add an additional function here to display the first vector of the verb. So once we get the search article file, we paste that information into a vector and then use that to get the actual file and set it to a data frame, and then we extract the data from there. So the first execution is searching for a full string, and we see that the full string score is 1. So this specific string is an exact question in the data set. Then in the second search, we search for a specific word inside the string, and as you can see, the score went lower because it's not exactly accurate. On both sides, we are seeing that the article files are S10 set 689, and in addition to that, we use the get content function to pull the first or second section of the actual file that was pulled here. So we got the verbiage from this file. In this second example, we're executing a search for a word string. And as we can see, if we look at pneumonia, the score is 0.7, about 0.7. If we look at this full sentence without the question mark, the score is 0.46, which is a little odd. And then last but not least, if we do a query search for the full term with the question mark, the score is 1. And again, we do the get content, and the get content gets us the actual file, at least a summary or a section of the actual file that has more information for the question. So in conclusion, we began with the objective of using the question answer dataset to search for strings with answers that we could rank and choose as the best answers. We used a dataset from Kaggle, reviewed and transformed the data. We performed some word term frequency checks and found the QA dataset had very little similarity to the raw dataset. We determined we needed an approach to focus the query on the questions and use the raw data to give additional information. We attempted a similarity approach with using SIM2, but instead chose to use and modify an existing function that focused on the question file. The result was a function that returned the data based on user's query and returned some file output with additional information. Thank you for watching. That's the end of the presentation.